Good morning, children. The previous video you had fairly good idea about what velocity is. So far you have come across speed, velocity, acceleration, and negative of acceleration is retardation. This much physical quantities we have understood. Now we will try to represent the motion, any moving body, by a graph. Sounds to be very confusing, am I right? But a graph stands for a pictorial representation. During this COVID pandemic also you must have seen graphs shown often, in which they give you an idea about the peak time, which part of the month the cases shot up and when was the case more flattened in different countries throughout the world. So such graph gives you a fairly good idea about what the entire picture is. You don't have to sit and read volumes over there. Similarly, during cricket match also, if you have missed the match, if you just go through the graph, then also you will get an idea about which particular team was playing well, which part of the game was better, which over was better or fruitful, when the number of wickets were more. All these informations are found or put up in the pictorial form, that is the graphical form. Correct? In the same way, the score, the marks, the academic score of a child can also be graphically shown. So in maths primary classes you must have come across different types of graphs. Say the histogram, that is a bar graph. Then you have the pie graph, isn't it? You have the curve. All these are different graphs which you must have come across in your primary classes. So graphically you can show the complete information. So here also we are talking about objects which are moving. Our chapter deals with object in motion. So such a object which is moving can be shown in a graph. Here the first graph which you come across for a syllabus is distance time graph. In distance time graph we generally take the dependent value on the y-axis and independent variable on the variable on the y-axis and independent variable on the x-axis. In distance time, which is independent? Yes, time is independent value. So time is considered on the x-axis and distance is considered on the y-axis. So if the object is moving with a uniform speed, the graph will look somewhat like this. Distance versus time graph. In this graph, you find that the graph moves quite straight, which is indicating the uniform motion. Now, this particular line which is depicting OA, or you call it as OB, or you can call it as AB, this part is said to be the slope, isn't it? It's tilting, so it's a slope. The slope in a distance time graph is always giving you the speed, because to calculate the slope, you take the standing line, that is the y-axis, upon the x-axis value. Now let me show you, if I want to calculate only this AB part of the slope, if AB is to be calculated, how will you do it? For calculation of this value, AB reading, you will extend the line parallel to the x-axis, okay, such a way that it forms a right angle triangle. From A you drop a line, isn't it? You drop parallel lines so that you get the reading on the x-axis, and from B you drop the lines, B and A you drop the lines to the y-axis to get the corresponding value. So now therefore you get a triangle ABC, a right angle triangle. Now what is the number corresponding to B? Number corresponding to B, it's not 40, it is one line below 40. So what is this number which is corresponding to B? For that you should know how many lines are there between 30 to 40. If you count, there are 1, 2, 3, 4 lines are there. So each line is reading 2. 30, 32, 34, 36, 38, 40. Clear? Same way over here, between 0 to 20, how many lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. That means 10 divisions are there. So each division is 2 because total 20. So each division is 2. So here also each division is 2. Here also each division is 2. So the number corresponding to B will be 38, and the number corresponding to A, this dotted line, will be corresponding to 28. So if you want to find out what is BC value will be 38 minus 28. Now same way for AC. The number corresponding to C and the number corresponding to A is to be read. What did I tell you each line corresponds to? 2. So this will be 42, then 44, 46, 48, 50, 52, 54, 56. So this number corresponds to 56 and this point corresponds to 42. So if I want to find out the AC distance will be equal to 56 minus 42. So the slope of the graph will be BC upon AC. So here the slope AB I have shown in calculation. Slope AB will be equal to 38 minus 28 upon 56 minus 42 comes to 10 by 14 and that is 0.65, which is approximately 0.7. Okay, this is one slope which I got. Now in the same graph we take up the second slope. The second slope I will consider the full graph, that is O to B. OB is also a slope. If I want to find out this slope, it will be equal to this full standing line upon the sleeping line, that is y-axis upon the x-axis. The number corresponding to B is 38 we have seen. Number corresponding to this base will be 0. So 38 minus 0, this full will be how much? 38. Number corresponding to this point is 56 we said on the x-axis and this is 0. So 56 minus 0 will be this full corresponding base will be 56. So 38 upon 56 will be the entire slope OB. So that calculation comes to here. OB is equal to 38 upon 56 is 19 upon 28 is approximately 0.7. Now the third slope which I take up in that graph will be OA. For OA it would be number corresponding to A and number corresponding to this part. This part will be, this is the base, so it will be corresponding to 0. And A is corresponding to 28. So this distance will be 28. Now this was 42, so 42 minus 0, so this base will be 42. So the third slope OA will be calculated as 28 upon 42 coming to 0.66, that is approximately 0.7. All the three slopes which we calculated are coming to 0.7. Why did we get a similar value over here? Because it is a figure or a graph on uniform motion, uniform speed. So when the distance time graph is drawn in this manner, it would be depicting uniform speed, and hence no matter whichever slope you take, a smaller or a bigger slope, you will get the answer same. An important question which is asked from this side is, this section is, what are the uses of distance time graph? This is a distance time graph, isn't it? So from the distance time graph, an important statement which you come to know is, you know whether the object is moving with uniform speed or not. Here, this is a statement. The distance time graph helps you to determine the speed of the object. Just now which I calculated and showed it to you. 0.7 meter per second हमें मिला था, ठीक है ना? So distance time graph helps you to determine the speed of an object. That is first point you come to know. Second thing which you come to know is, here I have written, it shows what type of motion is it. Means whether the graph is a uniform motion or a non-uniform motion, you come to know from the graph. Okay? Because when I say that whether you come to know whether it is a uniform or non-uniform motion, I mean to say like this. Let's suppose the graph is in this manner. The distance time graph is like this. Means it's an axis parallel to x-axis. What does it mean, you know? Time is running, but the distance is the same only. Suppose यहाँ पे 10 है, the distance is 10 only. Time runs, but distance is the same. That means an object is stationary. It is at rest. So distance time graph, if it is drawn in this manner, it will be stationary. Then you can plot two different moving bodies on the same graph. Here I have shown two different bodies. One body is starting from timing 0 and distance 0. The other has started somewhere over here. Timing is 0, but distance is somewhere, say 10 km away. So both of them are starting at different timing, different places. Okay, and then they are traveling. At one particular point they cross each other, means they must have met somewhere at this point. So when you draw two different bodies which are moving on the same graph, you can first of all find their speed. आप एक slope ले लीजिएगा, you will calculate the speed of this graph. आप इसके लिए ऐसे slope बना के यहाँ पे आप calculate कर सकते हैं. So you can calculate their speeds separately. You can come to know when these bodies will come and meet, means at this time they have met. At that time, what is the distance that can be known? Okay, so comparing the speeds and also coming to know whether they will meet or not, and when they will meet, at what distance they are going to meet. These informations you come to know from the distance time graph. Clear? A third thing which you come to know is, in the distance time graph, here, this is the slope I told you. This is the smaller slope which I have taken. This will be the bigger slope which I have taken. And again, this will be a final big slope, which I already explained in the textbook. Clear? So, slope can be calculated. I sum up the points again. Distance time graph will help you to find the speed of an object. Distance time graph will let you know what type of motion it is, whether the body is at rest or whether the body is moving, and if it is moving, whether it is uniform or non-uniform. Okay? The third point which you come to know is, as I told you, you can compare the speeds of the two moving bodies. And you can find out the timing and the distance when the two bodies will meet. These are the four important information you get to know from a distance time graph. The distance time graph, if it is non-uniform, how will the graph look like? This is how a graph of a non-uniform motion will look. See here, it is a slight curve, whereas for a uniform motion, you remember, it was a straight line like this. But this is a non-uniform motion, distance time graph. Okay, till here? Now, next type of graph which you come across is velocity time graph. Velocity time graph means you have velocity on the y-axis and timing on the x-axis. Velocity time graph, what will you get in the slope? Well, in the slope of a velocity time graph, you will get the acceleration. Why do you get acceleration in the slope of velocity time graph? Because you will get the y-axis to be the velocity reading and x-axis will be timing. And velocity upon time, that is change in velocity upon time, is acceleration. So slope of a velocity time graph will always give you the acceleration. Is it point clear? Now this particular graph shows about, can you tell me what type of graph it is? It's a line which is parallel to the x-axis. You might say that the body is at rest. You are wrong, because distance time graph, if it is given, then a line parallel to x-axis will be body at rest, stationary. But velocity time graph, if the graph is parallel to x-axis, it is showing that as the time is running, the velocity is still constant, 40 meter per second or 40 kilometer per hour. Clear? So if the graph is parallel to x-axis in a velocity time, it shows that it's uniform motion. But if the graph is parallel to x-axis in a distance time graph, then it shows that the body is at rest. Clear or not? So this is one information which you get from the velocity time graph. The second information which you get is the distance covered. The area under the graph. This is the area under the graph. Okay, the graph is this. The area under the graph will give you how much distance is covered from a given time. Here they have considered the timing after 1 second till 4 seconds. How much distance will be covered, that will be area under the graph. Is that point clear? This is the second thing which you come to know from a velocity time graph. The third type of motion which you are getting here, this is what I told you, the acceleration part of it. This shows a uniform acceleration. There is equal velocity difference in equal interval of time. Now here there are so many ways in which you can take the slope. You can take the small slope AE. In that case it will be ED upon AD, isn't it? And you can also take this OA slope, that will be AB upon OB. You can also take this bigger slope OE, which will be EC upon OC. What will be these values be? Let us check it out just now very quickly. First of all, if you take ED, what are the number corresponding to E and D? Here, this is 30 and this is 40. So each should be 2. 32, 34, 36, 38, 40, correct? So each mark is 2. So this number is corresponding to 36. And this value will correspond to 18. So ED distance will be 36 minus 18, comes to 18. Upon AD distance will be the number corresponding to D, number corresponding to A. Number corresponding to D is 20, number corresponding to A is 10, directly given to you. So 20 minus 10 will be 10, comes to 1.8. So what is the acceleration over here? 1.8. Let us take a slope over here, OA. What is this distance AB? The number corresponding to A is 18 and number corresponding to B is 0. So 18 minus 0, 18. And what will be this one, OB? 0 and 10. 10 minus 0 will be 10. So 18 upon 10 kitna aayega? 1.8. Achha, now let us take out the bigger slope, OE. The number corresponding to E is 36. Number corresponding to the C is 0. So it will be 36 upon OC. OC will be how much? 20. Sahi hai na? 36 upon 20. How much will you get? 1.8. So no matter whether you take a smaller slope or a bigger slope, you will get the answer constant because it is a uniform acceleration. Clear? And the area under the graph, if I want to know how much distance has been covered from 10 second to 20 second, then this blue shade which has been shown is the area under the graph. Means area of the trapezium has to be calculated. That will give you the distance covered by the body from 10 to 20 seconds. If I want to find from 0 to 10 seconds, then it will be this particular triangle, area under the graph. If I want to find out from 0 to 20 seconds, then it will be this bigger triangle which is area under the graph. So in velocity time graph, you can calculate the distance covered by a moving body from a given time, within a given time. The two more graphs which are pattern which you see is here, velocity time graph. But here what happens? The body is slowing down. Initially at 0 timing, the body was moving at 20 meter per second. Finally at 6 seconds, it has come down to stop. So it is a retardation. The body is slowing down. Here it is a non-uniform. See, it gets accelerated, then it goes slowing down, then again a slight acceleration, then finally it is slowing down. So a zigzag curve indicates that it's a non-uniform motion. Is that point clear? So the graph of a velocity time graph gives you the slope which is acceleration. Second point is it shows what type of motion is there, whether the motion is accelerating or it is uniform or it's non-uniform. Is that point clear or not? The questions which are given on this page 107 are to be written down. A very short question it is. First question is, what is the nature of the distance time graph for uniform and non-uniform motion of a object? Nature of the graph they are asking you. So you'll have to just draw and show it. Nature of the distance time graph for uniform, I have already shown it to you earlier. Which one was that? Here. This is for uniform motion and the figure 8.4 is non-uniform motion for distance time graph. Got this answer? Okay. Next is, what can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Time axis means x-axis. So if the distance time graph is parallel to x-axis, so kya hoga? Yeah, the body is at rest, distance time hai, please keep in mind. What can you say about the motion of an object if its speed time graph is a line parallel to the time axis? Speed time graph ka matlab? Velocity time. So velocity time graph, if it is parallel to x-axis, what does it show? Uniform motion. Clear? What is the quantity which is measured by the area occupied below the velocity time graph? Below velocity time graph, you get the distance covered by the body. Is that point clear? So you'll write down these answers in the notebook.